So this is the second part of electrolysis 2. So we'll pick up where we left off with the rules. And so if the positive ion present is more reactive than hydrogen, hydrogen itself will form. So here we have potassium. Potassium is a very reactive metal, much more reactive than hydrogen, so hydrogen forms. So you get bubbles of hydrogen gas appearing at the negative electrode. In the second example, we've got a choice of silver ions or hydrogen ions. Well, silver is a very unreactive metal, much less reactive than hydrogen. So the silver will take the electron at the negative electrode and you will form silver solid there. With the negative ions, you have to look here. If you have a halide, it will be the halide, or the element of the halide, the halogen, that will form. So we've got a choice between Cl- and hydroxide. Cl- is a halide, so you'll get chlorine forming. In the second example, we don't have a halide, we have either sulfate or hydroxide. So if there is no halide present, oxygen will form, and that oxygen comes from the hydroxide that's in the water. Now I'm afraid you have to learn this half equation, but I'm trying to think how many times I've ever seen it on the exam paper. Not very frequently, so it's not the be all and end all if you can't remember it. So those rules again: positive ions, check out if the metal is more or less reactive than hydrogen. If the metal is more reactive than hydrogen, as is the case in potassium, you get hydrogen forming. If the metal is less reactive than hydrogen, as is the case with silver versus hydrogen, the metal will form. And for the negative ions, if you have a halogen, you make a halide. If you have a halide, you get the halogen forming, and if you don't have a halide, you get oxygen forming, which forms from the hydroxide in water. So let's see if we can apply those rules. So let's see if we can apply these rules to these 6 electrolytes. The first one we don't actually need the rules for, because sodium chloride liquid is not an aqueous electrolyte. It's a molten electrolyte. So the chloride will form chlorine and kick out 2 electrons. Notice the negatives are balanced on each side, and there are no hydrogen ions present, so it must form sodium. So sodium plus an electron goes to form sodium. And as normal, at our anode, this is an oxidation reaction. Oxidation at the anode, because we are losing electrons. And at the cathode, we have reduction. I suppose a nice way of remembering that is reduction has a C in it, as does cathode, and there you can see the sodium is gaining an electron. Now, sodium chloride, we have to choose what we're forming here. Well, we've actually been told what we're forming, and it might be nice to think about why. Well, those are my 2 negative ions present. You can see we've got a halide, so the halogen forms, and you'll get the same half equation as is up here. And with at the cathode, you've got a choice between hydrogen and sodium. well, you should hopefully know from your chemistry that sodium is a very reactive metal, so that won't form. You'll be getting hydrogen forming, so the hydrogen will come in, pick up an electron and form, well, it will form H2. Hydrogen is a diatomic molecule, so you need to balance that by making two hydrogens and then balancing the charges, so it'll be neutral on the left and neutral on the right. Well, what happens if you electrolyse sulfuric acid, H2SO4? Well, you've again got a choice, but this time you've got a choice between sulfate, the negative ion, and hydroxide. So ask yourself, have you got a halide? No, you haven't. When we had NaCl, we had a halide. Here we don't have a halide, so we'll have oxygen forming. So we've been told we've got oxygen, and that comes from the hydroxide. So here's your half equation, which was on the previous slide. And at the cathode, well, unfortunately, well, not unfortunately, it makes it nice and easy, we only have one ion which will be attracted to the cathode because sulfuric acid relieves hydrogen ions. There are no metals in there, so it'll be hydrogen forming. Now this next example I think is copper sulfate. I've actually got the toolbar over the top, so I'm guessing a little bit about what we've got over there. I wonder if I could move this around. Oh, look at that, yes. So copper sulfate. The toolbar I don't think appears on the actual video. So what's going to be forming at the anode here? So we've got a choice of sulfate. So here's the sulfate, or hydroxide reacting. Have we got a halide? No, sulfate isn't a halide, so we'll have oxygen forming, and you'll get the same half equation as above. Oh, terrible writing. Over here, well, let's have a look at the two types of positive ions we've got. We've got copper and we've got the hydrogen from the water. Now, copper isn't a particularly reactive metal. It's lower than hydrogen in the reactivity series, so we'll actually get copper metal. We'll actually get orange copper metal being produced at the cathode, and so you can see that copper has a 2+ charge. It's going to gain 2 electrons and form copper atoms. So it's gaining electrons, so that's a reduction. Remember Leo Gurr. Our next example is potassium bromide. So our choice of negative ions is between bromide and hydroxide. Well, bromide is a halide, so we're actually going to get bromine forming, Br2. So that means the Br minuses are going to be changed into Br2, and that means each one is going to lose 2 electrons in an oxidation. And then we've got a choice between potassium and hydrogen. Now, hopefully you've remembered that hydrogen will form here, and that's because potassium is much more reactive. So hydrogen will be made. So we've got hydrogen, and we'll pick up 2 electrons, because we're going to have 2 H pluses, and they're going to form H2. And the final example is H3PO4. That's an acid called phosphoric acid, not often seen in GCSE chemistry. I'm just going to move my slide up a little bit to give me a little bit of extra room to write. And so we have a choice Our negative ions, well, we've either got phosphate. Now, you're not going to know what the ion necessarily is for phosphate, but it's PO4 3-, or hydroxide. Well, we haven't got a halide. We haven't got Cl- or Br- or I-, so we're going to get oxygen forming, and it will have the same half equation as up here and as up here. And the substance forming at the negative electrode must be hydrogen, because the only positive ion in there is H+. So we'll again have the same half equation as was there. So hopefully you can see the trends. And when we're reviewing these trends, we only really want to look at these bottom 5 reactions. So I'm just moving the screen accordingly. And you can see that if we had a nice reactive metal in the electrolyte like sodium, you don't make sodium, you make hydrogen. If the metal isn't quite so reactive, in other words is less reactive than hydrogen, like copper, the copper does form. Here the metal is potassium, it's more reactive than hydrogen, so hydrogen forms. It may seem a little bit counterintuitive. For the negative ions, all you've got to be doing is looking to see if there's a halide. If there's a halide, which there is here, which there is here, you get a halogen forming. If there isn't a halide, which there isn't here, here, or here, you make oxygen. And that oxygen comes from the hydroxide. So if you want to practice this further, there are 3 more examples here. I'm going to write the answers on the screen, but I'm not going to talk over them to give you probably a rest from my voice, but I'll put my working out down so you can see what's going on.